Hello students, so today we are meeting again in the t-test in Excel. The second part of this would be a continuation of the last week lecture. So last week we have discussed as to how to what is meant by hypothesis testing and how to conduct a one-sample t-test. So there is no readily available tool in Excel in order to do that. So we have to tool Excel in order to conduct a one-sample t-test. So let me recall as to why is it important to conduct a t-test. Why t-test? T-testing is used in hypothesis testing when we are deciding if we should support or reject a null hypothesis. So when you have a null hypothesis, you are going to accept the null hypothesis or reject the hypothesis. One technique that you can use in order to have the hypothesis testing is the so-called t-testing. The t-test is a way to tell if the difference between before and after results is significant or if those results could have happened by chance. So if, by taking two examples, if there is a significant difference in between the two taken samples, if you want to test that, you can use this t-test. For example, so one such scenario where you can use the t-test is this example, a drug manufacturer, that means a medicine manufacturer, might test a new drug and compare the before and after results to see if the drug is effective. So suppose that they are going to take a sample of 10 patients, those who have maybe high blood pressure. So we are going to test a new medicine as to we are going to control their high blood pressure by using this medicine. So what we can do in order to check whether this particular drug is effective, we can test the pressure level before the consumption of the medicine and after they consume the medicine. So by having the two samples compared at the end, you can see whether there is a significant difference in between the mean of the particular high blood pressure, okay, of the 10 patients. So that's a one particular example where you can use this t-test. So you have three options in data analysis toolpath. So when we look at the data analysis toolpath, let me share the screen with you. So if your data analysis toolpath is not readily available, so suppose this is our Excel. So go to data. So if I have told you that this is not readily available, so you have to make this available. Go to file, options, and go to add-ins. Here you can choose Excel add-ins, go, and here you can select analysis toolpath and click OK, so that the data analysis toolpath should be available. So when you go to data analysis toolpath, when it comes to t-test, there are three basic types of t-test available in Excel. So t-test, there are two samples for means, t-test two samples assuming equal variances, and t-test two samples assuming unequal variances. So in this video, we are going to discuss basically about t-test where two samples for means. In which occasions you can use this particular t-test. There are two samples for means. Okay, and now we will go back to the slides. Okay, I hope you can see. So two sample t-tests in Excel for means. The OV is as such. The two sample t-test for means is normally used when you are using files on the same subject. The example which I told you earlier, the consumption of drug usage may be you have a sales force. In your company there are 10 salesmen, and you are going to give them a training, and you are going to check whether the sales have increased after the exposure to the training session. So there we are going to consider the two same subject in two different situations. So here also you are given an example, the same example that I have briefed you before. For example, in a medical trial, you might want to know if a particular medicine is effective. So you test patients before the medication is administered and after. So that is given here. I have briefed before also the drug consumption example is the same example. So if you are going to have that sort of hypothesis tested, you need to use two sample t-test in Excel for means that particular t-test available in Excel. So there are three basic types of t-test available, ready available in Excel. But out of those three, if you are going to have the test twice on the same subject, you are recommended to use two sample t-test in Excel for means. Okay? And the t-test can tell you if the results from the trial have statistical significance or if the results probably occurred by chance. So by having done it, you are going to check whether the results from the trial has a statistical significance. So if it is medicine, has the medicine done a statistically significant change on the patient? So in order to check that, you can use this particular technique. Two sample t-tests for means in Excel. So these are the steps. Type your data in Excel. As the two sample t-tests, there are two samples for means is usually used before and after data. You probably have three columns. The first column for subject identifier. That means suppose that in your sample, if it is the example that we are going to discuss today is that we have 12 salespeople in our sales force. We are going to give them a training and we have to check whether their sales have significantly improved after the training session. So if that is the case, here the subject identifier means we are going to name our salesman as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since there are 12 people in our sample, 12 individuals in our sample. So step 2, state your null hypothesis. For example, your null hypothesis might be that the means are the same. So let me share the dataset with you. This is the dataset that we are going to read with today. So in order to start doing the exercise, you can enter you can pause the video and enter the data into your Excel sheet. So you have subject 9 in the first column where you have a subject identifier. So for the first individual, I have named the particular individual as 1, like 1 to 12 it is named. And the sales, what was the sales figures before the training session is given in the second column, and in the third column you have in column C after, that means after the training session, what has been the sales figures. Okay, so now we can start entering the data to the Excel sheet. Okay, since I have, in order to save time, I have already entered the data set to the Excel sheet. So this is the Excel sheet you can see. So here, now refer the slide. So here, what is the first step? So first step was to enter the data. Then we were asked to derive the null hypothesis. So what is the null hypothesis? H node semicolon. Here you need to have the so let me type the null hypothesis in the presentation slide so that state null hypothesis. For example, the null hypothesis might be that the means are the same. So what should be the null hypothesis? H node. So this has to be subscript. We can subscript it from here. So we are going to assume that the means are going to be the same, even though you are going to have a training session conducted, it's not going to make any changes on the sales values. So if it is that, so it's like equals okay, this would be the null hypothesis. So click the data tab in the then we are asked to click the data tab in data analysis impact. Then we are asked to here t-test here two samples for me. So here the I told you that in Excel we have previously options, but in this particular example we are going to have have the same subject examined after a certain change. So that's the reason why we are using t-test paired two samples for means. The paired two samples for means that particular test has been used in such examples where you are going to have the same subject considered. So I'll share the Excel sheet again with you. So we'll do it. So we have already typed the, we have already stated the null hypothesis. Now go to data analysis. Go to null hypothesis. Sorry, not go to. This is the out of these three, we are choosing this one. Okay, I hope the reason why we are choosing this one is clear because the same subject before and after sales people, before the training session and after the training session, what has been the sales figures. Now click OK. Input variable. So variable one range, I'm going to have included the label also, and variable two range is this one. So here hypothesize mean difference. So what I'm hypothesizing is that there is no statistical significant difference between mu1 and mu2. So that means the difference is zero. And since I have included labels when I was choosing the variable 1 and variable 2, I'm going to have label 6 and alpha 0.05. I'm going to let the alpha value remain the same. So I'm going to have the output in the same sheet. So choose it and I want my output here. Okay, so we are getting the output. So here you have the mean values for before and after, you have the variances before and after, number of observations, we have 12, and the Pearson correlation, that means there is a statistical significance. A positive relationship in between before and after the two situations, it's pretty obvious. So we are not going to look at those things. The hypothesized mean difference, that means in the null hypothesis, what we have stated is that the sales value before the training session would be equal to the sales values after the training session. So the hypothesized mean difference is zero. And the degree of freedom means alpha minus 1 is 12 minus 1 is 11. The important things that you have to look into are t set value and the t critical two tail value. Okay? So here there is a difference between one tail and two tail. The difference is that if in some occasions you would be looking at whether you would be looking at as to a very directional hypothesis. Uh, Okay, so the difference between one tail and two tail is that so you have one tail two values and two critical value here. So here, if you are going to have a certain direction, that means you are going to look at um, whether the value that you are going to look into is greater than one value or below a value. So if that is the case, you have to choose the one tail values. But here we are not as to sure we don't have such direction. The only thing that we are going to look into is that whether there is a statistical significance mean difference in between before and after situations. So there is no such direction. And also if you are not sure that you are going to look at a direction or not, uh, what is recommended for you to look at is the t-stat value here, which two of these values, two tail values, okay, rather than looking at the one tail value. So there are no such detection because we are not going to look at whether the value that we are going to get is above a certain value or below a certain value, but we are going to look at whether there is a difference in between the two values before and after the sales values. Okay, so we are going to look at the important things are the t-stat value, the t-stat value, and here we have the critical value, and here. Can you remember the decision rule that we have discussed in the last week's session? So let us look at the decision rule now. So here, his stat value is 0. His stat value is 0.28. Here, it's his stat value is T critical value is 2.200985. So when you, if you can remember the decision rule, and this value is, I have this values here. Okay, so the p value is 0.780139, which is above 0.05 our alpha value, and the t stat value is 0.2860, which is below, which is within the critical rate, the critical region. Okay, so here we look at the decision rule. I think you won't remember the, in case if you can't remember the decision rule. So we have followed all these steps. Now we are left with to interpret the result. So here look at this one. Steps in hypothesis, steps in decision making. So if you are going to look at the p-value and make a decision, if the p-value is less than the alpha value, that means in our case the p-value is, what was the p-value that we have got? It was 0.780. That means 0.7. So p-value is not less than 0.05 in our case. So we are going to move to decision rule 2, where our p-value is greater than the alpha level. So that means we are failing to reject the null hypothesis. That means there is a possibility of accepting the null hypothesis where the mu1 equals to mu2. So in order to be confirming, so here we are done with the first step, compare the alpha level we choose and p-value in the output. If the p-value of the output is smaller than the alpha level we choose, to reject the null hypothesis, but our alpha level is greater than our p-value is greater than the alpha level 0.05. So we are unable to reject the null hypothesis. Is it clear? And step 2, where we are going to look at the t critical value. So if the t value is larger than the t critical value, we are going to reject the null hypothesis. So the t value, look at our t value in the Excel sheet. T value is 0.2860. T critical value is 2.2009, which means that the value has been less than the critical value. So are we in a position to reject the null hypothesis now? No, we can't reject the null hypothesis. That means we are accepting the null hypothesis. The reason is because one reason is we looked at the p-value and the p-value was greater than 0.05, our alpha value, and we looked at the t-statistic value where we had the value as 0.28 and the critical value was 2.20. That means t-stat value has been less than 2.20, which was the t-critical value. That means we can't reject the null hypothesis. That means we are accepting the null hypothesis in the favor of mu1 equals mu2. So That what does it mean? What do you mean by accepting the null hypothesis here? That simply means that here that simply means that after the training session, there has not been such significant improvement in the sales force. So even after the training session given to the salesmen, the sales figures do not show a significant improvement or a drop. Okay, so that is the first part of testing the hypothesis. So here it was based on testing twice on the same subject. Therefore, we have used test t-test pair two samples for means here. So is it clear? Okay. Then we'll meet again in the next video where we are going to discuss about the t-test two samples assuming equal variances. Okay. So thank you.